Welcome to the latest edition of the Mind Gut Conversation podcast, a place to learn about the latest ideas from thought leaders in the area of health, food, the science of mind-body interactions, and the environment. Today, I have the great pleasure to talk to Rhonda Voskuhl, a professor of neurology at UCLA, where she currently holds the Jack H. Skirball Chair. She's the director of the UCLA Multiple Sclerosis Program and is the faculty neurologist for the UCLA Comprehensive Menopause Care Program. Dr. Voskuhl has a long-standing track record of commitment to women's health research, which initially focused on multiple sclerosis, an autoimmune and neurodegenerative disease that affects women 3 times more frequently than men. She served as the president of the Organization for the Study of Sex Differences from 2020 to 2022, and as the OSSD president-elect, was first author on a commentary in 2019 in Nature entitled "Sex is a Biological Variable in the Brain Too." With over 20 years of numerous grants and continuous funding from the NIH and National Multiple Sclerosis Society, her lab discovered a novel estrogen treatment strategy that can be neuroprotective through actions on estrogen receptor beta in the central nervous system, and she also identified a pro-inflammatory X chromosome gene. Dr. Voskuhl is a 2023 recipient of an 8-year ART35 grant for over $7 million from the NIH, which is awarded to approximately 10 neuroscientists per year across the US. In addition to basic research, Dr. Voskuhl has been the principal investigator on 3 clinical trials showing neuroprotective effects of estriol treatment on cognition and cortical brain atrophy, underscoring the translational nature of her research. Dr. Voskuhl was recently selected by the American Academy of Neurology for the highly prestigious John Distal Prize for 2024. Welcome to the show, Rhonda. It's a real pleasure to be able to talk to you after a lot of excitement was generated by your presentation at our recent annual symposium. I was going to start out with some of these different topics that we could talk about. And they're obviously overlapping. I'd like to start with the topic of sex-related differences in health and disease, which you have studied throughout your career. And I mean, the topics that I'd like to address briefly is cognitive decline, Alzheimer's disease, and MS. I don't know, and I don't remember if Parkinson's is another area that you have been looking at. Maybe we can touch on that as well. But so is there sex difference both clinically and so in the presentation of patients with these neurodegenerative diseases, and how important is that difference?
So thank you for having me. It's a pleasure to be here. I enjoyed, speaking at the conference with you and the work that you're doing. These podcasts are important, to educate all of us, and we all learn from each other as we did at the symposium. So yes, the sex differences are very pervasive, actually, in neurodegenerative disease. For example, Alzheimer's, of course, is 2/3 women, and that's even correcting for increased longevity of women. It can be statistically corrected for, and still 2/3 are women, which is striking, actually. It just makes you think, if we just understood this, maybe we could do something to fix it. It's a huge disease modifier, actually, if you think about it. Either something very good in men or something very bad in women, or both, right? And then same thing for multiple sclerosis. It's 3-to-1 women to men is the ratio, and same situation. With respect to cognitive decline, I think with just aging and otherwise healthy people, that's a hard one, because there's such a differential in the andropause versus menopause and some of the timing that goes on. So that's a more difficult one. But clearly, aging is bad for cognitive issues, and I think the differential timing could be due to some of the changes in hormones that differ in the rate in menopause versus andropause. We can get into that a little bit, but yeah. So the point is, there are very big sex differences, and I view this as a clue, and a clue of something that's very clinically important. That if we just figured it out, and figuring it out is not easy. It's sex hormones, it's sex chromosomes. That's not mutually exclusive, and there's a myriad of hormones, myriad of chromosomes, and so it's not like it's easy. But at least we do know there's something out there that is really affecting the disease, and if we were to reverse it or increase it, depending on whether it's good or bad, we could really have something.
I mean, considering how important that is and what impact it has, particularly with the increased longevity in our society, has research really been focused on this topic, or has the public awareness been focused on this topic, or is this something relatively recent with the Office of Research in Women's Health, forcing the NIH really to put a lot more attention on this and funding, grant funding on this topic?
It's definitely been forced. It's been ignored. I mean, I don't want to be political about it, but those are the facts. It's just been ignored. Even then, there was in the earlier days, the Office of Research in Women's Health was just asking people to not just only study male mice. A lot of the neuroscience was going on in male mice. A lot of the immunology was going on in female mice because they all knew they were more susceptible to their immune systems were. So I've seen both, because MS, where I've spent a lot of my life studying multiple sclerosis. It's both autoimmune and neurodegenerative, and it's just really interesting how scientists just have different questions, and they just want to follow the sex where it works the easiest, or basically the worst disease, and they want to go on to their question, but to ignore the fact that the other sex is basically either doing worse or doing better is really something it wasn't the question they wanted to study, and so they just didn't use the other one. And so there was a perpetuation of papers and science, and it was understood that most of the neuroscience was done actually in male mice and rats and so forth, and a lot of the immunology was actually done a lot in female, because of just the predisposition to get a really good robust disease or a model. So yeah, it was definitely ignored, and then it came to the clinical level. Well, actually, NIH started. They came up with sex as a biological variable, which I'm sure you're aware of that terminology, SABV, and that's in every grant. You've got to basically justify how you're studying both, and people didn't like it then either because they said, well, now I wanted to study something else. Now I have to study it ×2, and you're not giving me twice as much money. So this is the back and forth, and they're all reasonable arguments. But my point is just, though, that first of all, you could be missing a huge disease modifier. That's the first thing. And the second thing, it's really a win-win situation when you study both, because if anybody finds anything, whatever their question was, and they find it in one sex, if they look at the other sex, one or two things is going to happen. They find that whatever they just described in heart or lung or brain or wherever, it's also true in the other sex. It's just as true. It's just as important. So good, you just showed it's true for the whole population. Mm-hmm. And if it's not true, then you show, well, any treatment coming to that may be more optimal in one than the other, and you also may have a way to figure out why it works in one and not the other. So I just see it's a way to really move things forward in a clinically relevant way, and also to suggest some very basic science modifiers that you could come across. So it's really a win-win situation to study both.
Do you think this recent women's health initiative will make a big difference on that? Are these neurodegenerative diseases? Was that part of this development?
Yeah, it wasn't part of it. Actually, it started back with the Office of Research in Women's Health primarily. It started with the organization that I was president of, immediate past president of. I was president-elect president for 2 years, 4 years, and this is 6 years. And so it's been, and before me, many people came before me in that organization, and they were pushing for these things. And then it was the Society for Women's Health Research, SWHR. There's been this triad, really, of SWHR, Society of Women's Health Research, OSSD, Organization for Study Sex Differences, and the Office of Research in Women's Health, ORWH. So these worked, and when I was president, I tried to make that triad even stronger. And when it becomes strong like that, they can really, you have the advocacy, you have the money, and you have the scientists, really, in those three organizations. And when they come together, they can make robust and striking cases on why this is important. That's what has happened, and it has not been easy. It's taken tons of work by many, many people beyond me in these organizations. They've done a great job, and it's really finally come to fruition with Jill Biden and her colleagues recognizing this and bringing it to the forefront. This is going to be a major boost. what it's going to do, I think primarily if you read the announcements, a lot of the initial wave is going to be clinical work, which is really needed. So first we had to get over actually just even doing male and female mice or rats or animal models, right? And now what's still lacking really is this conversion or translation into actual treatments. And I think this White House initiative will help with that because a lot of it is written for clinical purposes. The state of the art was, they would do studies in one sex, and usually some of the other sex too, but they were not powered to see a difference. So they'll just, if you're underpowered in your trial and you don't design it that way, you say, oh, there's no difference, and I didn't find anything as a negative. Well, it's not a negative result unless it's a good negative, and a good negative means it's negative, but it's clearly negative because it was powered to see it could have been positive and it's negative. And so there's a big difference between just doing a study and really ignoring it and just say, oh, well, it was a little bit different, but not significantly different. Well, it wasn't powered to see a difference. So that's one thing. And the last step and now people are starting to have to report, some of the more nuanced data on sex differences in a clinical trial. What hasn't been done is really powering a trial prospectively to actually see and follow a sex difference. That's been rarely done. And what we've tried to do, some people have tried, it's just the beginning. We've done phase 2 trials to ask if there's a sex-specific factor that's actually been discovered by disentangling these differences. Make that and turn that now into a trial. So take it to the last step from bedside to bench to bedside, and that's not gone to phase 3. There are reasons for that. Some of them are economic because some of the things tried to alter sex hormones are very cheap and inexpensive, and there's not a lot of incentive to do phase 3 trials for literally hundreds of millions of dollars and thousands of people. So there are still hurdles that remain, but a tremendous amount has been accomplished in the last 2 decades. And I think the White House paying attention to this will be a huge boost, and it's to their credit. I think it's ripe for, and it's just low-hanging fruit. We have possible treatments that are right in front of us now from all the preclinical stuff and expanding on that, designing trials. So it's really ripe for the picking. Let's put it that way, to come up with discoveries that will be optimized for women or men.
Yeah, this was one of the big surprises, and we'll come back to this in the last portion of this conversation. This was one of the biggest surprise to me, how low-hanging these fruits really are in terms of focused clinical trials. And it's hard to believe that has not happened, earlier, because in many areas, I mean, just talking about, the area that I'm interested in, these brain-gut interactions, I mean, we don't really have these low-hanging fruits. It's much more uncertain what you should really home in for in terms of treatment, that's sex specific. And yeah, so we'll come back to this in the last section.
No, I mean, I actually see it as it's been de-risked, because then like a molecule that you choose and there's so many redundancies and pathways that things can happen. These are things that we know are relevant to the human condition. So they've kind of been de-risked for being totally irrelevant, if you know what I mean. That's a really good thing. I do think another obstacle, though, has been if you find something that works very well in one, it's not going to be all or nothing, but it works really well in one sex and it works partially well in another. That has implications for the market share for the drug that comes out. Just cut it, you know what I mean? If I don't think that's a women's drug or that's a men's drug. It goes both ways, and it makes people more likely. Only half the population now that would have taken it is now taking it. Well, they'd rather have not really know the difference, and everybody takes it.
Yeah.
I just think too many business concerns have driven some of the things over efficacy and safety.
Yeah, this is the sad thing about the whole pharmaceutical industry. I mean, the business concerns certainly at the highest level. I mean, the scientists in these companies we've worked with for many years. It's a very different thing once the lawyers get involved and the executives get involved and say, we're not going to, shortchange ourselves by just focusing on half of the population.
That's right. I think the scientists, that's why I never worked for a drug company, is because I didn't want to, and I know the scientists, I know they really feel strongly about what they're finding, and then to have the science is great, but it's a business decision. Well, that would be hard to take, which is why we're very fortunate to be in academia. We're very fortunate to have places like the NIH and the White House who support the kinds of things we do that really don't prioritize as the top thing, the cost and the dollars.
So let's get to the second point, which is also fascinating, and this is about the mechanisms. So we know, the sex hormones play a big role, not the only role, but a big role. And so you've published on these mechanisms. So I mean, maybe you want to explain to this. I mean, what role do sex hormones and specifically the receptors that they work on, what role do they play, for example, in these neurodegenerative diseases? People normally wouldn't think about this, but you've homed into sort of very molecular characterization of what the likely mechanism is. And so if you want to explain this a little bit.
Yeah, sure. So there are 6 differences in diseases, which is where we started. And but there are also 6 differences in hormones. So aging is bad for neurodegenerative disease. The age is one of the biggest risk factors you can have for neurodegenerative disease. And then while we can't reverse everything with aging, some of the things we can, such as the loss of sex hormones during andropause or menopause. So it's true for men too. The timing is just different. And so for men, testosterone drops by 1 to 2% per year at the age of 30 to 70. That's a very, very, very slow decline, but it's happening. And women actually do really well with estrogen up until about 51 years old. They maintain it quite well, and then all of a sudden it drops completely and absolutely. And so that, to me, that was very interesting, because testosterone is converted to estrogen in the brain by aromatase. And the other thing is estrogens are known to be neuroprotective. It's been known for quite some time that estrogens are neuroprotective. So it's been known in many animal models. It's been known in women who get early ovarectomies that they have cognitive issues that are otherwise healthy. It's been shown time and time again. The thing that was lacking is to kind of tie together how this could actually be the same thing between females and males, that, females could be basically maintaining pretty well, and the males could be having difficulties at the ages of about 40s or so, which is true in MS and true in MCI, preceding Alzheimer's disease. But boy, once those women go through menopause, then they're worse than ever. And so it can all be due to actually decreased binding to estrogen receptors in the brain, and just differential timing of that loss. And that's why women are so bad after menopause. Of course, catch them eventually by the time they're 70. Go ahead.
Just a couple of words about estrogen receptors in the brain. A lot of people wouldn't think about. So they think about it has to do with reproduction, and that these estrogen or these sex hormone effects are primarily peripheral. What's known about the importance of these estrogen and androgen receptors at the brain level?
Well, first of all, we know that it's much more than the reproductive system, and that's what I've studied my entire career. I've studied the non-reproductive aspects of sex hormones, and we know those are important for example, with estrogen, because in the UCLA Comprehensive Menopause Care Program, we have people they've brought in GYNs, they brought in a person for bone. So we know estrogens act on bone. We know they act on breast. We know they act on heart. We know they act on brain. And so everybody's known for a very long time that these aspects of estrogen that are beyond reproduction. It's a multi-organ system, and menopause is a multi-organ system problem, actually, and that's why UCLA's brought in an expert in all these different organ systems to work with the GYNs. Brain specifically, we know that the estrogens are lipophilic. They get through the blood-brain barrier. They bind. The question that hadn't been addressed as well, I think, is the regions that are vulnerable to estrogen loss. That's primarily hippocampus and frontal cortex. That's why you see cognitive issues in women who have lost estrogen either through surgical menopause or natural menopause. Of course, splitting surgical from natural is how you take away, it's not just age, because it also happens when they have ovaries taken out at a younger age. And you see changes not only in cognitive issues in both of those situations. Those cognitive issues, by the way, it's not IQ, it's not global cognition, it's not mini mental status. It's things like verbal memory, working memory, some quick processing, issues. And these are the kinds of things you see. It makes sense that they relate to regions such as the hippocampus and frontal cortex. Makes sense. Same thing if imaging is done. It's not entire brain. It's not global atrophy. It's not global problems. It's region specific. And I think as a neuroscientist, we all know you cannot lump the brain into it's just one organ. I mean, it's extremely different from region to region to region. Gene expression has been shown now. We were leading in that as just showing the basics of regional differences in astrocyte gene expression, even during health, from one region of the brain to another. So spinal cord versus cerebellum versus hippocampus versus cerebral cortex. It differs even during health. And of course, it's going to differ when you insult, if there's an injury, whether it's traumatic or inflammatory or autoimmune or chemical or neurodegenerative, it's going to impact, they have a different baseline from region to region to region, even within the same cell. And then you go to a different cell and you have also differences in gene expression from region to region. So it makes sense that you can see regional effects of loss of estrogen. It's hippocampus and frontal cortex. You see cognitive issues related to those regions. You see MRI. It's usually atrophy and functional connectivity in those same regions, hippocampus and frontal cortex. And of course, they spread. Then when you get to something like Alzheimer's disease, things are going to spread out and things are going to be worse. But I think we all know the way to think about Alzheimer's disease is to go in early and not late. That's why the whole field's focused on mild cognitive impairment, not Alzheimer's disease anymore. And my view has been that, when you think about Alzheimer's disease, I think we can all agree there's no great treatment for it. The treatments are just symptomatic and they reduce demise by a little bit. And so again, the whole field really is on mild cognitive impairment, that 10 years or so prior to Alzheimer's disease. But you just think about that. What's prior to mild cognitive impairment? Well, 2/3 of Alzheimer's patients are women. And MCI is the prelude to Alzheimer's. So the thing that is most prevalent before MCI is actually aging in women. And that aging is menopause. And so it just it's very interesting that the same regions affected by, menopause in healthy women, frontal cortex, hippocampus, some cognitive issues, and you just see, we won't know, we won't know the answer to that. I'm not saying that's the case, but it just makes such logical sense, that what's earlier than MCI? Well, it's actually menopause in aging women, right? And so we won't know the answer to whether that's actually the case until we have a treatment where we can treat cognitive decline in healthy women. Until you have a treatment that you can give and they can withstand, safely, they can take it for X number of years, you'll never know whether that can reduce the incidence of MCI and AD. We'll never know. They'll just say, oh, well, yeah, it's logically, it makes sense, but will we ever know? And the reason we don't know is because we don't have, the HRT has been so flawed in the way that those trials have been designed. They've ignored cognition. The MRIs were not done looking at, phase 3 studies did not have a cognitive domain specific primary outcome. The large old studies didn't, if they did MRI at all, they looked at global measures. And so, a few groups have done a great job with it. Mayo Clinic's done a good job. UCLA's done a good job, but there's been very little done on, HRT and optimizing and tailoring it.
So to interrupt, but could you explain briefly HRT? So for a lot of people, this may not be.
Yeah, hormone replacement therapy, that's what everybody thinks about with menopause. They're all trying to decide, should I be on HRT? Should I not? The pendulum when everybody should, and then when everybody shouldn't. And the whole time they pretty much ignored the brain. And just to put it in a nutshell, they're basically, the trials were giving Premin, which is pregnant male urine proteins. It's a mixture of a lot of different estrogens isolated from pregnant mare's urine. And the next thing that was given, and that I can just tell you is not shown neuroprotection. It's a low dose of a mixture of different estrogens. The other one that has been given is estradiol, and these are basically given not to improve cognition. That's not what they've been given for. They've been to reduce hot flashes. And hot flashes, by the way, they go away after a few years untreated. So this isn't a long-term problem. And both of those will work on hot flashes. They've been FDA approved for hot flashes. There is no treatment that's been FDA approved to improve cognition in menopausal women. There is none. And the reason is because the trials haven't been done to be a primary outcome for that primary and powered and set all the inclusion exclusion criteria up for that as a primary. It's not been done. I think based on all the preclinical data that estradiol could be neuroprotective. But the problem with estradiol is it binds very strongly to estrogen receptor alpha. There's estrogen receptor alpha and there's estrogen receptor beta. So estrogen receptor alpha, I think you can see neuroprotective effects. The problem is you can't take it for very long at a very high dose. Dose matters with neuroscience. Higher doses work better, just like a lot of things in the body. Sometimes there's biphasic effects, but with estrogen, higher doses are looking better. I'm sure if you push it too high, maybe not, but by and large, when you're in physiologic range, the higher doses do work better than low doses. And unfortunately with estradiol, since it binds ER alpha in the breast, that is the estrogen receptor that's associated with breast cancer. Tamoxifen blocks ER alpha in breast. That's a treatment for breast cancer. And so everyone is very scared. Women have no options. They have these cognitive issues. They're very worried about it. Sometimes they have ApoE4 genotype. They have a family history of Alzheimer's. They're very worried about it, and rightly so. And then when I think about taking HRT, they're offered Premarin, which there's no evidence that's neuroprotective. And estradiol for hot flashes, then they've got to go off of that after a few years because they can't take it at a high dose or long duration because it binds ER alpha in breast. It's a strong estrogen for binding ER alpha. So anyway, what we've done is we focused on estrogen receptor beta.
But one thing before you say, so there was sort of a big thing that happened at the HRT trial. HRT trial was discontinued, was stopped because of these side effects that, as you explained, probably were due to the fact that the estrogen receptor alpha was stimulated at the same time. What was the main reason for stopping this trial? Was this breast cancer incidents, or?
A lot of it was because one of the big ones was because it did not reach it wasn't because of side effects. It was because it did not reach its primary outcome, which was actually to decrease cardiovascular risk. And actually, it had as a positive, it helped osteoporosis. Oh, and had some benefits effect on colon cancer. They had less hip fractures, they have less colon cancer. It had some good things. And then I think there's always the concern for breast cancer. They were also older. They were over 65. And so you're always worried about, even with birth control pills and smoking, or you're always worried about stroke, deep venous thrombosis. These are the kind of things you worry about. But I don't believe they were stopped because they didn't hit the primary. And then with respect to cognition, they didn't really look at it. And then there was some data that said, oh, well, maybe the ones who had the progesterone did a little bit worse than the ones that didn't get the progesterone added on. You've got to have progesterone when you take estrogen because estrogen causes uterine endometrial hyperplasia, which you always counter that in a birth control pill or a HRT with giving a progesterone with it. So you don't get that uterine lining getting thicker and thicker. And so some of the data suggested that the progesterone add that on could be bad. It also depends on the type of progesterone. It was medroxyprogesterone, which is thought to be a little bit worse than some of the others. So the thing is, these things just haven't been tailored for efficacy and minimized for toxicity. And the disappointing thing too was there was some evidence. Oh, well, let's look at cognition. They looked at dementia. They often didn't say whether it was Alzheimer's or vascular dementia or a mixed dementia. There wasn't information on and it wasn't powered to see that. So it was just looking back to see if there was any effect. And it's just very, I think it's just really disappointing how little attention has been paid to cognition in menopausal women, because 70% of them have cognitive issues. And they're just kind of told, oh, well, that you're just getting older. And well, it looks like it's more than that. It's associated with brain abnormalities on the brain on MRI, the animal models. We have the paper in Nature Communications that I sent to you. And there are things going on in animals as well, in brains when you look at pathology as well as MRI for atrophy during menopause at midlife. So I just think now, hopefully, again, with the changed environment that we live in, that we will start to address these cognitive issues in menopausal women, because they're very serious. And to do that, you should treat it like every other problem that we have. Pharmaceutical companies do this all the time. They have a drug and they say, well, we want to maximize efficacy and minimize toxicity. And so here what you do is you maximize estrogen receptor beta can be neuroprotective. We've done a lot of work with this, and other people have too at this point, that estrogen receptor beta can be neuroprotective, and it binds very weakly to estrogen receptor alpha. And so that's the thing. drug companies do it all the time. They make, and we've done this too at UCLA, you make novel ligands for beta that doesn't bind alpha, or just a naturally occurring something that's safe that more naturally binds ER beta strongly and ER alpha weakly. Anybody would do that, but I just think there hasn't been the drive for whatever reason to focus on this issue in menopausal women with cognitive issues.
I mean, you've done some, talk about, the mechanism of these two receptor types and what they influence, and you've done some pioneering research on this topic. So a lot of people don't think about that. I don't know if it's 40% of the cells within the brain are actually not neurons or the glial cells, or so this whole effect of the estrogen beta receptor, what you've shown to a large degree, or maybe exclusively, is on not directly on the neurons, but on these glial cells.
So the way you figure out whether a hormone, when a hormone acts on more than one receptor, and when a hormone acts on more than one cell, what we've done is, and a lot of people do this too, you do a cell-specific knockout, right? You basically, you knock out one receptor, not the other, and you let them have the hormones like they would have, and you just knock out. It's a loss of function study, and it's very specific. And with all the genetics that happen now, we can all do that. We can knock out in one cell or another based on the promoter that we use to drive the knockout. And so what we've done is we've knocked out ER alpha or ER beta, and we've knocked out those cells really on the different cell types. And everybody would think, oh, and I did too when I first started, oh, it's going to be the neurons. It's going to be the neurons. It's going to be a direct effect on neurons. And you know what? Twice I've been burned on that because it wasn't. Astrocytes actually act on ER alpha actually acts very strong on astrocytes, and I'll tell you what astrocytes are in a minute. And ER beta acts very strongly on microglia and also on oligodendrocytes. And this is important because the astrocytes, well, actually now ER beta can act on astrocytes too. That in aging, it also depends on the model, whether it's multiple sclerosis or whether it's aging, or I'm sure whether it's stroke. And so again, these neurological diseases are not all alike, of course. And so some of them are going to be more driven by one glial cell type than another. And so what you have to do is you go into each, we do health first. We do health with just aging. And then we also do the aging with an overlay. We do just the disease, and then we do the disease with the aging. If that makes any sense. Aging only, just the disease in the younger ones where you can induce it in mice, for example. And then you come in, you add those two together. You really have to parse through that. And then you're like, oh, lo and behold, it makes sense because it was acting this way and so in aging. So those cells are very important. The non-neuronal cells are extremely important because astrocytes maintain the synapses. You have a neuron with its axon and its synaptic, and then the signal goes across, and neurotransmitters go across, and that's how you have signal transduction. So astrocytes kind of maintain that synaptic health. Microglia are very important because they can cause some synaptic stripping, and the remodeling can be good or bad depending on the circumstance, health or disease or latent disease. And then last but not least, the oligodendrocytes are important because they can cause remyelination or making the myelin back, which is very important, something like multiple sclerosis. Even Alzheimer's can have some white matter injury, even during Alzheimer's disease, white matter disease. So we found that hormones seem to be acting very, I wouldn't say ubiquitously, but I would say very specifically on astrocytes, microglia, and even oligodendrocytes to mediate remyelination, synaptic plasticity and repair, or just the astrocytes to maintain the health of the synapse. And we found actually the neurons to be a little bit of a passive player in this. It's almost the glia are the ones that are important in maintaining the environment. So the neurons can actually, of course, they're the most important ones for the function, the neurons, axons, and synapses.
So then, once these hormones act on these glial cells, so how do they get to? How does the damage get to the neurons? Does that involve?
Well, if you don't maintain the synapse, you'll have the synapses will actually pull back, and they won't get the nutrients, and they'll die, and they'll be like a wire stuck into the wall. It's losing its prongs. And eventually the wire itself will undergo damage, axonal degeneration. Eventually it'll cause demyelination, and you lose the myelin or the rubber around the wire. So when you don't have the support of these glial cells that are maintaining the health of them, or they're stripping it away, or they're, it's just, you're just damaging the wire and the prongs and the rubber around the wire, basically, and you're not maintaining it in a state of health. And also it's been shown in axons and the neurons that you need functional functional conduction is very good for synaptic health and axonal health, neuronal health. If you don't use it, you lose it. And it's true with the nervous system as well. And so if you don't have the glial cells and you maintain the use of them and the health of them, eventually they're gonna lose, they'll be pruned out or they'll be lost.
One question I have is, which I really brought up with you, is so our interest, and my group's interest has been, as you know, on the microbiome and how it signals to the brain. And one of these communication channels is through the immune system, which also acts on the LPS, these membrane components of microbes that can make it through the blood-brain barrier and then act on specific receptors. And so their inflammation is a major thing. So this induction of inflammatory changes in the glial cells, which then produce cytokines, which then damage the neurons. So I just wonder, I mean, there's a lot of attention, obviously, maybe more than, for the sex hormones. There's been a lot of attention on the role of diet in causing this low-grade immune activation in the body and in the brain. So listening to you, I mean, I can't help to think about that there's got to be some interaction, particularly in postmenopausal women, of this dietary induced low-grade immune activation with the loss of a protective factor, the estrogen beta stimulation. Have you looked, I mean, has anybody looked at this interaction between the estrogens and the food-induced changes at the brain level?
So I think that, well, actually estradiol, which is of course the one of the natural cycling, it's bad for breast, but it is the naturally cycling estrogen of the menstrual cycles. We know that, of course. And estradiol is actually very anti-inflammatory. Estriol is somewhat anti-inflammatory. I'm talking about the peripheral immune system. So estradiol is very anti-inflammatory in the peripheral immune system. This would be affected by this low-level inflammation that you're talking about related to the microbiome and triggering low-level inflammation. So that is something that should very much be studied in menopause versus non-menopause. And to, again, to remove the confound of aging, if you had surgical menopause, it'd be even better, because then you don't have the age, it's a short time frame. And I'm just saying a way to do a clinical study, right? It's easier. It's going to be easier, again, in women than in men with andropause, because the time course. I do think, though, that there is some evidence that it's not my area, the microbiome, but I do think people have sent me references before, just passing my desk, whereby it looks like hormones can affect the microbiome. And so I think it's definitely playing a role. It's not something I've studied, but I can't imagine menopause not having an effect on that. And actually, I think it's also true, because if you talk to the allergist, that's an interesting one too. If you want to think about it's a flip side of it, but it's still the same principle about, is there an effect or not? And there's a lot of evidence that allergies, food allergies no less, change during menopause. Mm-hmm. So that's that's going to be overreactivity, whether it's gluten or something else, right? There are lots of hints that I think there's going to be something there. I really do. I think there's definitely going to be something there with menopause and changing in the immune system and how that affects the ability of the microbiome to cause low-level inflammation.
Yeah. And this is interesting. I mean, it's not really what I want to discuss with you, but just to bring this up, I mean, David Merriweather in our center is doing these studies on this recycling of estrogen, where the microbiome plays a big role. So, estrogen molecules secreted, these glucuronidated estrogen getting into the small bowel and then interacting. Microbes can deconjugate it and, metabolize it into a form that's reabsorbable. So, and that depends on what composition of microbes an individual has. So depending on what your microbial ecosystem is, you'll either reabsorb more or less of these recycling estrogen molecules, which I'm sure at some point it's also an area really interesting to me how kind of neglected these areas are. But it's an area that's definitely going to get more attention in the future, particularly in post-menopause. Is this a source that some women have less problems after menopause because they have a more effective way of recycling the diminished amount of estrogen that gets into the small bowel? But I think it's just another example how these sex-related research questions have really been neglected, have not gotten the same attention as.
Yeah. It'd be interesting to know what the effect of estrogens are on ulcerative colitis, right?
Yeah.
Because that's also kind of a big picture thing where the inflammation is bad, and is it getting better or worse during menopause? And I always use I always go back to clinical observations, and I always go back to, well, what's the effect of pregnancy when estrogens are high? And what's the effect on a disease, whether that's myasthenia gravis, multiple sclerosis, whatever? Alzheimer's, they're not going to be, there's not much overlap there, obviously, because of the age situation, but just the flip side of pregnancy versus menopause, because you've really got estrogens high and estrogens low. And when you start to see, like in MS, for example, MS is better when women are pregnant, and then it's worse when they go through menopause. It really gives you some clarity about the role of estrogen.
And that's similar in ulcerative colitis. So during pregnancy, it's similar.
Well, that's interesting, isn't it?
Yeah, and there's also
ulcerative colitis is worse when they go through menopause. Is that worse?
But honestly, I can't answer. I should be able to answer this question. I will look it up or talk to my colleagues, but I can't answer.
You should look at food allergies, because I think there's something there.
Yeah. I mean, food allergies definitely seem to be more common in women. But I don't know the effect of menopause, if that goes down, or up. But another sort of interesting, intersection of, since you brought up this topic of inflammatory bowel disease, so there's pretty good studies, epidemiological studies, that have shown that long-standing ulcerative colitis, just chronic ongoing inflammation in the periphery, is a risk factor for developing early cognitive decline. Nobody has paid attention to this in gastroenterology. So there's a whole consequence of that people are discussing, to be really aggressive with suppressing even mild forms of activity of the inflammatory bowel disease, because that will have. And there's lots of research questions that could be answered. I mean, after total colectomy for UC, would that the risk for Alzheimer's and cognitive decline go down? And what's the interaction with menopause? It's.
Yeah, I mean, it of course reminds me of multiple sclerosis, because that's clearly an autoimmune disease, and it's clearly that they have cognitive issues, and of course people there would argue that it's going to be lesions, but they don't get lesions at the hippocampus, but they do get lesions at the white matter tracts going to the hippocampus and to the frontal cortex. But the fact that you're finding these observations in what you just mentioned, that is a situation where you don't actually have white matter demyelinating lesions, because they're not MS patients. But that could suggest for the MS field that some of the cognitive issues, which are very clear in MS, they definitely have cognitive issues, and it could suggest there may be a non-MS lesion mediated low-grade inflammation in the periphery contribution, right?
Yeah, absolutely.
How that before you just said it, but it's interesting.
So let's move to the third part of topics that I wanted to talk to you about. So this implication for therapy. So you mentioned a couple of times, this is an area with relatively low-hanging fruits, and after the HRT trials were stopped, but in view of a lot of pretty convincing preclinical data, this would be a time where you would think that, these clinical trials with a different approach, more focused approach could really make a huge difference for,
Yeah, I think that's what's so exciting, and that's what I think the Biden White House initiative is going to really help with. People are going to have some money to actually do some trials that could be for some things that are not that expensive. We've done several clinical trials. I've done 4, and 2 of them are multi-center, 2 of them were just UCLA kind of smaller. Well, they're phase 2As, and the others were 2Bs, I guess. If you had to put those numbers on them, but anyway, yeah, with MS, the women, we've done clinical trials of estriol, recapitulating pregnancy, like mid-pregnancy levels of estrogen, because it binds your beta, not alpha, very strongly at all, mostly beta. And we have 3 papers. One showed reduction in it's mildly anti-inflammatory. We actually have 4 papers, but mildly anti-inflammatory for these MS lesions in the white matter. But what became so interesting was that we also showed that you can actually have, when you combine it with an anti-inflammatory, you can see these neuroprotective aspects, which is an improvement in cognition. So that wasn't just, a slower decline. It was actually improvement, which is, I said, wow, that's super interesting. There must be something going on, not just decreasing the inflammatory attacks. You've actually got to be doing something in the brain to have synaptic plasticity where you can actually have improvement over placebo. So they were tested at the same time. It wasn't a placebo effect because it was placebo controlled. And so that was really interesting. We saw that within a year. And then we also saw there was a decrease. And by the way, it did correlate with the levels. Levels matter. So higher estriol levels caused more cognitive improvement. In the next paper, we saw that there was a slowing of cerebral cortex atrophy in the estriol compared to placebo. And the last paper was it reduced serum neurofilament light chain, which is a marker for neurodegeneration and aging, and it reduced that. So we've got really neat data in MS. And then and that's using a higher dose of 8 milligrams, which is, it's not that high, but it's a pregnancy dose. For menopausal women, I think a better replacement, of course, than estradiol, which binds the alpha breast, would be estriol, because it binds the beta and not alpha very strongly. And the Europeans know this because they've been given estriol for a very long time, really for hot flashes like everybody else did. And they're using it at 2 milligrams. It's been given for over 40 years in Europe. It's been shown to be safe. The thing, they haven't looked at for cognition either, though. So I've given a talk just in October in Milan, and they said, we need a registry. I said, yes, you need a registry. Just keep track of this. You're giving estriol to women. So there needs to be cognitive testing done. It needs to be the cognitive tests that are actually affected during menopause, not mini-mental status, which is just for people that have, early Alzheimer's disease. That's what we're looking at. We're looking at something, these early phases. That needs to be done. There needs to be imaging done that's region specific for changes that we know occur. And so those need to be done. And then we're doing that in the United States now. There's a company that licensed to use late patents with Cleopatra RX, and they're basically forming a registry where they basically give estriol to menopausal women with cognitive decline. They use the dose in Europe, it's a 2 milligram, the safe dose, and they're going to start keeping track of it. And I've submitted now a proposal to the White House initiative to formulate this even further into, really studying something that's safe and relatively inexpensive to see what's the effect on the brain. That's the question.
So this seems to be sort of a really intriguing situation. So it's been used in Europe, but they've not paid attention to its potential benefit on cognitive decline. And it's not been used in the US extensively. But it works really well in these preclinical studies and in your early, phase 2A studies. It seems like for any other drug, there would be a lot more activity to bring this to the market, or actually.
Well, the reason is because of finances, because estriol, if you take estriol and you have to take a progesterone with it, that also has to be designed what the progesterone should be, the timing and everything, because progesterone can have some counter effects on estrogen. Different medroxyprogesterone, not the same as progesterone. So I'm an inventor on over 15 patents for UCLA. I work for UCLA. They're not mine. They belong to UCLA, and they're in the US and they're in Europe, but they're not a chemical patent. they're a use patent on how to, what's the estriol dose, the progesterone dose, how to take it, when to take it, the packaging. And so that's the problem with that is, and I went to the Anderson School of Business, no less, to see why pharma always says, oh, it's good, science is great, the safety is great, but they say you'll never be able to get a company to do a phase 3 trial for over $100 million unless you charge at least $10,000 a year. And I said, but that's not going to happen because it costs, it costs less than $100 a month. And there's no way people can just go around it and use off-label treatments. And so, because compounding pharmacies do prescribe estriol, actually. There was a time 10 years ago where there was a pharmaceutical company wanting to make the compounding. They had I don't want to say the drug company's name, but they had a synthetic of an estradiol, a synthetic estradiol that they wanted to be used for hot flashes, and some of the women wanted to take estriol for hot flashes because they're scared of ER-alpha on the breast, and so the company pressured the FDA to shut down the compounding pharmacies in the United States from making estriol because those trials haven't been done. Well, they won't be done, you know what I mean, because of the finances, because they're cheap, and so they said they were going to shut them down. And actually, it was the women's advocacy groups that came up and they took out full-page ads, and I can't remember if it was. It was the Wall Street Journal and the New York Times, or I don't remember, but two major major newspapers, back when we had newspapers about 10 years ago. And, well, we still have them, but, internet. But anyway, major push by the advocacy groups say, don't take away our estriol. It wasn't shown to be unsafe, estriol. It was just cheap. And a company wants you to, the FDA to shut down the compounding pharmacies from prescribing it. And so actually Congress passed a resolution, I forgot the number, but you can look it up. Congress passed a resolution saying they're not going to force the compounding pharmacies to close down making estriol because there was no reason to do it.
So could a woman today that, notices early cognitive decline, post-menopause, could that person get a prescription for it?
They do it all the time. I mean, we're doing it at the UCLA Comprehensive Menopause Care Program now. People have done it for years who are aware of the safeties and benefits. But the problem is just, there's no big pharma behind it. There's a little company who's licensed UCLA patents, Cleopatra, but there's not been the huge push to do the phase 3 trials, to get drug approvals, to get the insurance. The insurance isn't going to pay for anything except estradiol for hot flashes. And they'll pay for that, but they're not paying it because of cognition, because they don't know, and they can't take it really for that long anyway. But anyway, yeah, no, people do it right now. Compounding pharmacies can make estriol now. It's a little problematic if they don't know the dose, the type, the timing, the progesterone, all that business. But people do try to do it. Which some GYNs will do it, and some haven't even heard of estriol. So
no, it's sort of coming in with the hippocampus, cognitive decline. I've sort of entered into this area again from the microbiome world and from some of the metabolites that are being generated by the microbes from polyphenols in our fruits and vegetables. So it's thought to be one of the main mechanisms by which a plant-based diet exerts health benefits on the body and on the brain. And these large molecules that often referred to as antioxidants, which they are in the test tube, but not when you ingest them because they can't be absorbed. So they go down to the microbes, are metabolized, are broken down into simple phenols and molecules that then act on the microbes and are being absorbed into the bloodstream. And there was unusual for the supplement industry, a big NIH industry study, the Cosmos study that showed if people ingested or consumed one of these compounds, flavanol, that I think it was over a 3-year period, there was significant benefit in terms of cardiovascular disease, but also, brain cognitive decline. And that's been studied all the way down to the mechanisms, how it affects endothelial function. So it's a vascular effect.
Yeah.
But it's the main effects on the brain, that's why I bring it up, are also on the hippocampus, on the dentate gyrus in this case, with brain imaging. And so we're trying to do a study on this, looking at this in more detail with a supplementation of flavanols. So I just wonder, listening to this conversation, at some point there could be actually combination therapy.
Yeah.
with an anti-inflammatory or with a polyphenol and
Yeah, absolutely. It's 3-arm study or 4. You could have placebo, you could have one, you could have the other, you could have both, right?
yeah.
That's a great study. What was your experience with trying to get something like the flavonoids? Like, you know, you don't hear of a big company picking that up either and doing a large phase 3 with thousands of people and, you know, hundreds of millions of dollars. So what was the experience trying to get that to move to the ultimately to the big time market?
Yeah, so at the time when this study was planned, it was planned, believe it or not, between the company Mars, the chocolate company, which has an interest. One of their interests is in these healthy foods, and they were interested in developing or proving that eating their chocolate would actually have a benefit on
Good.
on the brain. But the thing is, in regular chocolate, you know, these polyphenols are pretty much removed. Even if you eat dark chocolate, the processing steps remove almost everything of it. So chocolate itself does not have that benefit. But if you take that molecule, you know, that's in the bean, and which is now marketed as a supplement, has not really received the main attention. But we did get, after 3 attempts, we did get a big NIH study together with Centre in Ireland on evaluating the effect on, you know, mild cognitive decline and detailed brain characterization beyond the
Yeah, no, that's how we did ours too, as the NIH finding it. It's so as the NIH steps up, and they're stepping up again. I think the question though, for it to reach everybody and to get, you know, it's really the ads and the marketing, you know, it's got to be a company like Mars would be great.
Yeah.
It's fantastic that they did that. You know, kudos to them. But that's what it's going to take until the masses can actually have something like this, I think. But you know, we're trying with our small company that we're doing, and we'll see. But it's the same thing, really. It's something that can be very safe and very low hanging fruit,
Yeah.
but maybe too low hanging in a way. I don't know. I guess we're running out of time, but yeah, you know, it seems like there's been a lot of analogies between some of the things that you're doing and some of the things I'm doing.
Yeah, I would see there's kind of a convergence in the future.
Yep.
I would say in 5 years from now, you know, if there's clinical trial data available, that this is definitely going to be treatments for some of these devastating neurodegenerative diseases, that it's not just one compound.
Absolutely. Absolutely. And I think that people have been talking about healthy lifestyles for a lot of reasons. I don't think it's going to be, things are not mutually exclusive. It's not yours or mine or that one. Or, you know, it's basically healthy diet, exercise, and maintain your hormones.
Yeah.
And they say the healthy lifestyle thing, but we're just getting to the molecular mechanism of that, and actually, but trying to do it in a scientific way where you get the right doses too, the right timing, the right everything. It's not just, you know, because sometimes they ER beta, they talk about soybeans. Well, you'd have to eat so many soybeans. I know there's a dose effect, blood level, so you can't eat enough soybeans to get enough ER beta. You know what I mean? So for some things, it's just the way we're trying to do it, I think, is the way to do it, to really get to the mechanism, the dose, the timing, where it's acting, what cells it's acting. And you know, I think things are moving in the right direction. Things are good.
So would you say, you know, sort of wrapping up a sentence, if you look into the crystal ball, what would you say in 5 years or in 10 years from now, where this field is going to be? So both in terms of MS, but also, you know, cognitive decline in women post-menopause. Will there be major changes in the clinical availability of treatments? Or
I think there will, because I think we're so close. I think we've identified the region, the cell. We've got drugs that can work, and I don't think the finances are going to hold us back. And especially now with the White House initiative, I think that's going to be enough to put it over the edge. I think it's going to happen.
Great.
Yeah.
Let's close with this optimistic view. And thank you so much, Rhonda. It was really enlightening for me to listen to you as always.
Yeah.
And
well, I enjoyed it too, and I enjoyed learning what you're doing. It's been very interesting.